So what I wanted to show here was mixed stoichiometry. In this problem, let's look at this one. This one's really interesting. So a regular antacid tablet will react with about 80 milliliters of 0.05 molar HCl in the stomach. How many milliliters of CO2 gas at 37 degrees Celsius and 1 atmosphere will form from the complete reaction of 80 milliliters of 0.050 molar HCl, right? So this one's really interesting. So step 0, I better have a balanced equation. This is actually a net ionic equation that we talked about. When we have a metal carbonate react with an acid, we produce carbon dioxide, water, and an ionic compound, right? And I gave it to you, it's balanced. So they basically said that the tablet will react with that amount of stomach acid. So let's assume that it's the calcium carbonate's either excess or just the right amount, right? That's kind of an assumption in the problem. And so this one's really interesting because we're given aqueous, right? We're given a molarity and a volume of HCl, right? Oops. So we're given information about solution. So it's not volume of a gas, but it's volume of a solution and concentration of a solution. We can use that to find the moles of the solution, or the moles of the solute in the solution. Once we have the moles of the solute, using stoichiometry, we can find the moles of the carbon dioxide gas. Once we have the moles of the carbon dioxide gas, we can use gas laws. It's got to be PV equals nRT to find the volume of carbon dioxide, right? Every time you're going to do for mixed stoichiometry, just consider that for each step, no matter what information is given, you could be given grams, or you could be given concentration of a solution, or you could be given gas information. Whatever you're going to do, you're going to go from measurable quantity of your known to moles of your known to moles of the unknown, and then to another measurable quantity. And so that was kind of the setup before that got erased. This is the general case. This is the specific case up here, right? So we're going to use solution information. We're always going to have the mole ratio if we're doing stoichiometry. And then we're going to end with the gas laws. So I have a balanced equation. I'm going to find moles of the known. And so in order to do that, let's find the information. So the acid's my known. I have 80 milliliters. Oops. 80 milliliters, and it's 0.050 molar HCl, right? And so we're using concentration. This is from before. This is a couple lectures ago. Molarity is equal to moles per liter. Therefore, moles is equal to liters times molarity. And I think the only trick to this is I'm going to have to convert the milliliters to liters. 80 milliliters divided by 1,000 milliliters per liter. The milliliters cancel, and that gives me liters when I do that. So that's my volume in liters. Then I'm going to multiply by the concentration. And instead of 0.050 molar, I'm going to convert it to 0.050 moles per liter. Why did I do that? I did that so the liters will cancel. But I'm still doing this operation, concentration times volume. And that's going to give me some moles, 0.0040, 2 sig figs, moles of HCl. So I just did this step. That's step 1. I went from quantity of known to moles of known. Now I want to go from moles of known to moles of unknown. Find moles unknown. So I'm going to take that answer from before, 0.0040 moles of HCl. What's my mole ratio? We need to look back. Aha, it's 2 moles of HCl to 1 mole of carbon. Oh, yeah, carbon dioxide. Okay, so 2 moles of HCl, 1 mole CO2. So just divide by 2. And that's gonna, oh, that's really nice. That gives me 0.0020 moles of CO2. And then, so now we're gonna go to step 3, which is, now that I have moles of the unknown, I'm gonna use the other things I'm given to find the measurable quantity. And what did I wanted to find the volume, I think, right? The volume of CO2. Okay, 3, find volume CO2, which is my unknown. Okay, so ideal gas law says volume is equal to nRT over P. So I want to find N, which is I already have, is 0.0020 moles of CO2, pressure of my gas, temperature of my gas. It's 1.0 atmospheres. It's not STP because I'm at 37 degrees Celsius. So 1.0 ATM. 37 degrees Celsius plus 273 is 310.15 Kelvin. So V is going to be equal to nRT over P. So N is 0.0020 moles of CO2. R gas constant is 0.082058 liters times atmospheres over moles times Kelvin, and temperature is 310.15 Kelvin divided by pressure 1.0 atmospheres. My best I can do is 2 sig figs again. So this becomes 0.0509 blah blah blah. So 2 sig figs would be 0.051 liters or 51 milliliters. So that's how much gas I burp when I take some Tums, essentially, right? Okay.